Consider the function here. Answer the following using calculus. That means we cannot answer just by graphing this function on our calculator. So we need to use calculus, means derivatives, etc. We need to find the intervals on which this function is increasing or decreasing, and find the x values where the function, where f attains its local max and min values. So to see if the function is increasing or decreasing, we first find the critical numbers or critical points, critical numbers. For we find its derivative. So derivative of this function is easy. X cubed, that's 3x squared plus 6x minus 9 plus 0. No need to write. Now we need to find the critical numbers. For we set the derivative 0. Okay, now we set the derivative 0 and solve for x. 3x squared plus 6x minus 9 equals 0. So this is a trinomial, quadratic trinomial. 3, 6, 9. 3 divides all coefficients, so we can factor 3 out. That leaves x squared plus 3 goes twice minus 3 goes 3 times equals 0. And we can divide both sides by 3, so this 3 has no contribution, so x squared plus 2x minus 3 equals 0. Now we factor x squared, so x times x. 3 is just 3 times 1, that's the only option. To get positive 2, we get positive in the bigger, in front of bigger, and minus 1 here. Okay, so from this, either x plus 3 is 0, that means x is negative 3, or x minus 1 0, so add 1 both sides, we get 1. Okay, also we can see 1 makes this 0, negative 3 makes this 0. So we got two critical numbers, and this is a polynomial, and the derivative is also a polynomial, so these are the only critical numbers. I mean, this is defined everywhere. The derivative is defined everywhere. Okay, now we need to do a sign chart or interval test. So the domain of the function is all real numbers because we got polynomial, and we have two critical numbers, negative 3 somewhere here and 1. Now we pick a representative from each interval. Negative infinity through negative 3, maybe negative 4. Here we can pick 0. Here we can pick 2. Now we plug these representative values into this derivative. Okay, just in this derivative. So f prime. Okay, to check the sign. So plug in negative 4 here. 3 times negative 4 is squared. Use your calculator. 3 times negative 4 is squared. Okay, that will be positive, plus 6 times negative 4. That's a negative number, minus 9. So check your, use your calculator, and it comes out to be plus. Okay, the first derivative will be just positive, so I'm writing plus plus. Plug in 0 here. 0 plus 0 minus 9, it will be negative. Okay, we don't need the exact value, we just need the sign, plus or minus. So plug in 2. 2 is squared, and plus, plug in 2, so we get plus here. So first derivative is positive here, negative here, again positive here. That means the function, because we are answering about the function, so we use the derivative just to determine these signs. So the function itself does what? When the first derivative is positive, the function is increasing, decreasing, and increasing. So we write in this way. So the function is increasing on here negative infinity through negative 3, and here 1 through positive infinity, and decreasing on here negative 3 through 1. Okay, that's the first part, intervals on which the function is increasing or decreasing. Now we need to find the x values where the function attains local max and min. So local max and min, that means we need to find just the x values. We need to look at the critical numbers and see from there. Look at this sign chart. At negative 3, left of negative 3, the function is going up, like going up, and after negative 3 it's going down, and again at 1 it's going up. So we have graph something similar to this, and this top is at negative 3. This is not the exact graph, but negative 3, and at 1 we have the lowest point. So not the lowest, but relatively or locally. Okay, this is local min, this is local max. So we are just asked to find x values. So local max at x equals negative 3, and local minimum at x equals 1. In fact, we can find the local max value. The value would be just negative 3 plug in back here in the original question. Okay, same thing for local minimum, but the question only asks x coordinates, and this is it.